and this. Okay, so these are the 4 slides that you have to explain for diffraction through single slit. Okay, in many of the books they are directly going to slide 3. They are directly going to slide 3. Okay, I'll give, okay, they give the expression for I and then go for this slide and then this graph. Okay, so some of the textbooks only give you these 2 slides. Okay, but I think you need to explain the previous 2 also to get this. Okay, the same one. Okay, it's a repetitive. Okay, so when alpha is equal to 3 pi by 2, okay, first maxima, okay, first secondary maxima. Okay, so alpha is equal to 3 pi by 2. They have substituted it as a naught square sine alpha by alpha whole square. So that gives you 4 by 9 pi square I naught. What is the original amplitude? Sorry, intensity I naught. Now what is the secondary? I mean first secondary maxima amplitude 9 by 4 pi square I naught. 9 by 4 pi square I naught. Okay, that means this amplitude is smaller than the previous, right? And then I2 4 by 25 pi square I naught. When you go for 7 pi by 2, that is a third secondary maxima, that is 4 by 49 pi square I naught. So what do you see? The I naught maxima value is continuously decreasing as you go from this principal maxima to secondary maximas. Okay, now this is the intensity distribution. Okay, D is the slit width. Okay, I've been using small dm. Okay, in this figure or in this, okay, I've taken this figure from this particular site. Okay, in this site he is using capital D, but in my expressions or in my derivation I've been using small d. Okay, and this is the intensity distribution. Okay, see, okay, this width is also large. Okay, this width is also large. Okay, central maxima has got very high intensity and very broad. Secondary maximas are of low intensity and their okay, breadth is also decreasing. Okay, that is to be understood in this figure. Okay, the same thing. Okay, okay, this is how, okay, intensity distribution is being given. Okay, when this D is increasing, then the breadth is increasing, but the amplitude is decreasing. That is to be considered. Okay, linear width of the principal maxima. That means you are trying to find the linear width of the principal maxima. Okay, the principal maxima's width. You see that the principal maxima width is increasing. Okay, with the decreasing D. Okay, decreasing D. W is equal to 2f lambda by capital small d, where small d is the width. Small d is the width of the principal mag, width of the slit. Okay, so this is another important point that will be asked in problems, okay, or in explanation. Okay, what happens? Okay, distance of, okay, along the screen, distance on the screen. Okay, central maxima increases in width as the slit width decreases. Important point. Okay, central maxima width is increasing as the width of the slit is decreasing. As the width of the slit is decreasing, okay, the width is, okay, this width is continuously increasing. That's the point explained here.